graphs and 10 equations that you have to match up together, and people always get very confused by it, and I'll help you at the beginning. But let me just remind you that if we started with the equation y equals x squared, could you match up what graph goes with y equals x squared? A parabola starting at 0. So like the equation would be y equals x squared. The graph would look like this, sort of. That's a terrible graph. And a table is just an XY chart. I always make my XY charts vertically, and I think part of what people struggle with on this homework is they make their XY charts horizontal. So they do like X, Y, but you're still just matching the points up, right? So like if I picked 0 for X, you'd get 0 for Y. If I picked 1 for X, you'd get 1 for Y. And 2 for X, I'd get 4, and so on and so forth. And so we'll look at the homework because we should have plenty of time to start it. And it's just kind of matching all up. I'm sure some terrible child has probably already written all the answers in your book for those. So that'll be great. But if not, you actually have to think a little bit. So you're just checking right now. How about this? You can kind of shorten this up a little bit, but here you go. A pizzeria sells a rectangular 20-inch by 22-inch pizza for the same price as its large round pizza, 24-inch diameter. If both pizzas are the same thickness, which option gives you the most pizza for the money? There you go. When am I going to use math in life? What's the better deal on pizza?
You really do that?
No, but I really do check at Kroger because they do the math for you, and in the corner they tell you how much stuff is per ounce. And so I check the different ones to see which one am I getting more for the money.
I feel like that's so much work for like 2 ounces.
But sometimes I do with diapers. So it's like, do I buy the bigger box of diapers? How much is that per diaper? Or the smaller, if you buy the smaller box of diapers, you're paying like 18 cents a diaper, whereas if you buy the big box of diapers, sometimes you can get them for 9 cents a diaper. So I do the math for that.
So you do send miles for the work.
If I'm buying 100 diapers, you know, how many diapers you can't use this in the, like, before the body spray? You should just use cloth diapers, and then you don't have to buy it.
Ew, that's just
It's a very eco-friendly way to go. I'll just destroy the earth. You can look up, diapers are one of the longest things to like, what's it called? Like decompose, biodegradable, right? Diapers like last in a landfill for like 80 years. Because what they put in it to like keep the moisture away from the baby is just weird, I guess. So that's why you're supposed to use cloth diapers and be friendly.
But can you imagine how gross that is?
That's why I don't really should have. Where can you get a rectangular pizza?
That's what the pizza, the box ones. You get a Pizza Hut box, then it's rectangular. Isn't it?
When I was a kid, back in the olden days, when you went to Little Caesars, they had a big rectangular pizza called the Bigfoot pizza. It was a big rectangle. But now Little Caesars just has the $5 pizza. 24-inch diameter. Same thickness, so that's important. What am I trying to find if I want to know which option gives me the most pizza for my money? And in Italy, do they have rectangular pizzas? We don't really either, not very much. Except for Little Caesars. Or the box pizza at Pizza Hut, which is kind of weird, I'm not gonna lie.
No,
It tastes different.
Rice cakes.
It tastes
Failed their health inspection.
They failed their health. Don't tell me that's my favorite. Oh my goodness gracious. That's my favorite pizza.
Yeah,
So wait, are they closing? No, they'll stay open.
Yeah, they failed it the last 2 times.
most pizza for the money. What math term are we trying to find on this?
Thank you for your book.
If I'm trying to find how much has the most pizza, I'm trying to find the area, because they're the same thickness. So like, all right, we're just gonna take 20 times 22. How do you find the area of a circle?
Isn't it pi r squared?
Oh, you're geniuses. So do I plug 24 in there? 12. I was trying to trick you.
12 squared times 5.
We're talking about inches of.
To the Italian.
Get that circle.
No, circle is this.
Do they have better pizza in Italy? Have you ate pizza here yet? Is it better? It's good? What?
Not as good as
Oh, not as good. You guys have the really big, like, thing. Do they like actual spinach on your pizza and like actual mozzarella and like
our pizza are thinner.
thinner? Good stuff on top instead of plastic cheese. Plastic cheese. It's like all plastic.
If you have to wait 2 weeks.
2 weeks. Dry ice. So there's this pizza place in some little town that I've never heard of, but it's like super busy all the time. I'll have to find out the name of it. It's on like on the way to Avon. I don't know, but it's like owned by Italians and it's really good. Probably like the better pizza you can get. So where? Days?
It's not Dave's All American. That is not owned by Italian.
No, not Days.
They sell Italian food.
Well, that's Danville. It's in between Danville and Bay Bridge.
Like
And then
pizza
you
Hut?
turn and you go. No, just never mind. It's on
No.
36.
Pizza Hut is really good. La Rosa's. No, I know what you're talking about. It's like kind of in
That's like frozen pizza.
ish. And it's like an Italian restaurant. It's like a mom and pop type deal.
Yeah, it's like in this little town. We went to it.
Mario's.
That's that.
We went to it and it was started raining. Like we sat outside because there was no seating inside because it was so full. And then it started raining, so they just bring you boxes because they're like, there's no seating inside, so here are your boxes to put all your food in. And my husband's like, is this normal for it to be this busy? He was like, they're like, normally it's like a short wait to get a table. In this small little town, it was really busy.
Are they closed on Tuesdays? Because I know what you're talking about, I think. But they're only
They're closed one day a week, yes.
on Tuesdays. They're closed on Tuesdays. I like Chicago.
What's it called that?
I don't know what it's called, but it's really good.
I know what you're talking about.
I think it's probably like
I know,
closer
right?
to Italian.
Is it a real thing?
What's it like?
Papa John's is pretty good.
Okay, back to that. The weird thing about this section, I think, is it's all mixed together. So, like, you're going to have to match tables and graphs and linear functions and quadratics and square roots and all that. You're going to have to solve two-story problems. And then also they're just going to throw this in, which I think we did this on our test yesterday, right? Like, this should be like, oh my gosh, we just did this. Why is it still here? Algebraically. Why are we still doing it? Quadratics never go away. Complete the square quadratic formula factoring. I don't care which way you do it, as long as you do it correctly. So hopefully you did this correctly on your test so that I'm a grader.
Do it right now.
Do it right now. I can just stop teaching you grade.
No, I meant like solve it right now.
This?
Yeah.
Yeah, I am.
No.
You.
No, she meant she solved it right now.
Yeah, I didn't
Oh,
know.
okay. I'm with you.
Yeah, I was
I thought she was bossing you.
no, I didn't ask
She
you.
was like, yes, do it. Okay.
You're a little boss type of guys.
This,
I think it's
not factorable, so, I'm gonna complete the square because I like to complete the square. You can do the quadratic formula. See if we agree. So I guess I could left that 8 over there.
I think that should be fine.
Half of 4 is 2, 2 squared is 4. I can break that up. That's 4 times 3, so that's 2 radical 3. So I need to do the quadratic formula too. Did you get that quadratic formula? I'm guessing you have to, on the bottom of the quadratic formula, you're gonna get 2, so probably you can divide everything by 2. Did you get that answer? Quadratics just really never go away. Like they're pretty much in everything we do, except for when we get to trig, and then until we factor with trig, and then it's like there again. So we just need to love quadratics, or at least learn how to do it. So that's good. Why are my numbers so big? That's the real question. Did you get that? Just took up too much room. Can I go? We got this right on test yesterday, right?
No, we didn't. That was an example.
Oh, that's how you do that problem?
This is the big idea from from Algebra 2. Like, after you did like 4 chapters, you finally got to this thing called the fundamental theorem of algebra, which is not that exciting, but it says that when you solve a function equal to 0, that certain things are true. I don't know that you need to write every word of this, but you need to know that the following things are true. And I think there's a test that Mr. McClure gave you, maybe it was my test, that it said, which of these things, or name all the things that are the same as a 0, right? You remember that? Probably not. But all of these things mean the same thing, right? A root or a solution is what you get when you solve a function equal to 0. A 0 is what you get when you solve a function equal to 0. And the other one is, you could also say x-intercept. And so the reason that I make such a big deal about this in Algebra 2, that I put on a test that you have to list them all, is because sometimes the directions say different things. Sometimes it says find the solutions. Sometimes it says find the zeros, or find the roots, or find the x-intercepts. And I just want you to know that all of those mean, when you solve this equation, all of these things mean the same thing. So that's all that says in a whole bunch of words. We could also throw in that a factor, right, and we'll talk about that later, but factors kind of lead us into zeros and roots and x-intercepts and solutions. It's like chapter 6 test or something. It's not ridiculous that I remember that.
What's it asking?
I could check my filing cabinet over here. My test. I should have texted Mr. McClure yesterday and told him that there was water all over the room, and he, would make him happy that he wasn't here to deal with it. Yeah, all over his desk, because it's right underneath the vent, and the wind blew just right, and the rain just comes in, and it was all over his desk and his computer, and all the stuff was wet, so they couldn't plug anything in the whole day, because they were afraid of getting electrocuted, and the phone jack's fried, the phone won't work anymore.
It has a new feature. It probably needs a
He
phone.
came in yesterday and he said, "Can you come in for a minute?" And I went there. He pointed to all the water standing on his computer,
Can you just laugh?
and he said, "Is this normal?" I'm not gonna lie, it's happened before,
Has it really?
but it happened to Mr. McClure.
How did the water get in there?
Apparently, somehow, it's like a whatever. I don't know. I'm not good with stuff like that. But when it gets so hot in the wintertime, like when it gets so warm, then that something opens up and air comes in from outside. What's that called?
The vent?
I don't think that's the right word. But it's okay. And if the wind blows just right and is blowing the rain, then the rain will come in the vent and then it just pours out.
Oh, yeah, Mr. Pumpkins looks like it. That's why it smells bad.
That's why it smells bad. Because now we have mold and mildew under the carpet.
It's a poor guy, new teacher.
I said now every time it rains, he's going to have this thought of, I wonder if it's raining. I wonder if it's raining.
As long as an accurate read of the better.
Welcome to. You don't have to write this down. I just like to show you it because I like you to read your book. But this is this guy, Julia. 4 problem-solving steps. This is what he says. To solve any problem in your life, math or non-math related, you should do this. And in your book, no one ever reads their book, so sometimes I like to read it to you. Because I think that the authors of this book are kind of funny. There we go. Julia died in 1985, which means born 1887, died 1985. He died, I was born when he died. I was 3. It says, George Polya is sometimes called the father of modern problem solving, not only because he was good at it, as he certainly was, but also because he published the most famous analysis of the problem solving process, How to Solve It, a new aspect of the mathematical method. And these 4 steps are well known to most mathematicians. You guys hate story problems, and I think it's silly that lots of people don't even like to try to solve story problems because there's words in them. And I don't know that I really go through all these steps, but make sure you understand what it's asking. Devise a plan. Should I make a graph? Should I write an equation? Should I draw a picture? Carry out the plan means actually solve it. Look back to see if your answer makes sense. In ECA Lab yesterday, we solved a problem about the area, and someone got an answer of -8. They did not look back because you can't have an area of -8 of something. And so that's what that means. I just like to read you about George Polya because I think it's funny. She can do breakfast. Little George. My brother's name's George. You don't hear many Georges these days.
My dad.
The one who doesn't have his license.
The one that has license.
Wait, no.
No. do all the things you're supposed to do as parents, like teach your kid how to drive. So. And he lives far away now, so I can't teach him how to parallel park, so. I'm just
That's
like,
so not important though. You can miss out on tests and still pass. That's the problem.
again, it's,
He's 47.
but like no one ever works with him. Like no one ever worked with him. He didn't take driver's ed, so he just goes and tries to wing it on the test, and obviously doesn't do so well. And I asked him after he failed. He just took it last year again, and he failed. And I said, well, did they tell you what to work on? And he's like, she said pretty much everything. It's just sad.
Why don't you teach him?
He lives in Kentucky now. Like my parents were all.
He lives in Kentucky. I was hoping maybe he like lived in Chicago or New York, where there's like actually public
No, he lives like in the
transportation.
middle of nowhere in Kentucky. So
How does he get groceries?
Bike.
my parents drive him around.
They live in Kentucky? Why do you live here?
They live with him.
Why do you live here?
Wow. Why are you still here?
I know.
They moved back to Kentucky.
They were living here,
Yes, they moved back like 6 years ago.
and you were like right here.
Yes, my sister lives in Greenfield, and I live here, and they all live down there, but that's okay, because they're kind of weird, so. I don't know.
But your sister's not. She's
Right,
normal.
we're the same ones, that's what they do.
Oh,
Everyone else is crazy.
you guys are very much alike. Did she look like you? I don't know.
You guys ask too many questions.
Yeah, I completely failed. I did it, like the lady was like, right, I'm trying to do it, and I was like, okay, so I did, she was telling me like all these steps I had never learned before, like, you did that completely wrong. I was like, I literally just said everything you're supposed to do.
I practiced parallel parking so much because I was so worried. I'm pretty sure I can parallel park better than I can just park in regular space at this point.
Yeah, I can too, and she was like, right, now try to do it, and I was like, okay,
Again, I feel like this section is just a hodgepodge of problems, but I just wanted to make sure we remembered if we have a square root in an equation, how to solve it. Step 1 is the square root has to be by itself, otherwise it gets really ugly, but this one is. And then we got to get rid of that square root. So what are we going to do? Square it. And if we square this side, then we have to square this side too. And so what's super great over here, if I square this, the reason we do that is they're inverses, so they cancel out, and you just get x plus 4. But don't make a silly algebra mistake over here. Remember that there's 2 of these, and you have to FOIL that out. So don't say that that's just 4x squared plus 25, because there's a middle term in there, and that's what people usually forget. So then that would be 4x squared minus 10x would be minus 20x plus 25, and then look, I have a quadratic again. Hooray! If I subtract 1 over there, is that minus 21x? Minus 21? Stop me if I don't add correctly.
Wait, would it be plus 21?
Yep. So I don't think I would want to complete the square on this, because we'd have to divide by 4, and that doesn't seem like very much fun. And we could take 4 times 21 and get 84 and try to think of things and multiply to give you 84 to add to 21, but I'm guessing you're probably just going to do the good old quadratic formula. So that would be 21 plus or minus the square root of 21 squared minus 4 times 21 all over 2 times 4. It's like once I start, I can't stop writing it. I think I dislike the quadratic formula just because I hate that I have to have a calculator to do all these numbers. Like I feel like I should know all this in my head, but I don't. 105. Is that right?
Yeah. So I don't know if I have one.
I thought that's what you were right put on square, like that's not.
No, I just didn't know. I always do this all at once, and I think I would recommend that you do it all at once because it usually saves on negative errors.
I have a question.
Yep.
If you have one like 35 or something, and you know you can break it up to 5 and 7, but neither of them can cancel out, can you just leave it 35, or do you want?
Only break it up if you're going to take out a perfect square. So like 105, does anything go to 105? That's the perfect square? I don't think so. You don't think. Which means I think you could leave your answer like this. What you do want to make sure, though, is when you have a square root function, that you don't have any extraneous solution. Remember that word extraneous? I mean, sometimes you get an answer that doesn't actually work. This is kind of a weird answer, so I don't, we'll see if this happens to work out to be negative. But we can't have a negative under here, right? Like, there's no way you can have an imaginary number equal to a real number. So you kind of want to check, especially with ones that work out nicely. Make sure that that doesn't give you a negative. So I'm just going to very quickly on my calculator take 21 minus the square root of 105 and divide that by 8. And it's still positive, like that works out to be like 1.34. That's not going to give me a negative, so I'm good to go here. But you might want to just remind yourselves, I think there's one in the homework that we'll probably end up talking about tomorrow, that you have to check your answers. Like if you would have gotten an answer of -7 here, you would have had to say that doesn't work because -7 can't be irrational. Okay? Oh my goodness, this is homework. I want you to write this down and then get your paper out and label it however you do it, because I want to look at 1 through 10 with you, just because I'm not going to do them all with you, but just to kind of, we'll see if the answer is going to be
I was so fast, but I was like scrolling down and she circled the circle on the graphs. I also saw last year, I must have Michael Jackson as the issue white, or the issue black, and it's white.
So on page 81, that's the 1 through 10. So you kind of look at those. And it's kind of like what I showed you at the beginning. They give you 1 through 10 are the XY charts. And then if you look, A through J are the graphs. And K through T are the equations. So what I think, I like to do stuff in order. So it's weird. Like I think 1 through 10 you can't really do in order. For me, I work best with equations. I'm a math teacher. I like equations best. So I try to match the equation with either the graph or with a chart first, and then kind of go from there. If you remember what graphs look like, you can probably match some of those up, right? Like if you see a parabola, you know what has to be in the equation. X squared. If you see just a straight line, then it's a linear equation. So that's like y equals mx plus b. There's a square root one in there. I do want to show you something about the graphs there. Like on A, you see how on that graph it shows, I don't know, something like this, and it says -2, 14 by -4, 36. That's how this book shows graphs. And what do you think that means? You know what this means down here? -2, 14 by... This is your x-axis, so it's telling you that the x-axis goes from -2 and it ends at 14. And this is giving you the y-axis, so it's telling you that it goes from -4 to 36. So that when you're matching those up, you might be like, how can I tell the difference between this linear equation and this linear equation? Is you have to look at the values there. Does that make a little bit of sense? So, I don't know, let's try to look at one of these here. Let's look at, do you want to just look at number 1? Yeah. Look at number 1. Wow. Should I answer the first? Doesn't help to have, I mean, yes, you get them all written down, but it doesn't help to understand it. And they might be wrong, so yeah. Just saying. I wouldn't trust it.
Oh, it's the graph, I mean the chart to the graph?
And to the equation.
Wait, and the equation are.
And the equations are below the graphs, right? So for each number, you're going to have 2 letters. You have to pick the graph that's with it and the equation. When I look at this, step 1 is I look to see if it's linear. Because if it's linear, that means it has slope, which means it's going to be increasing or decreasing at a constant rate. Yes? So on this one, the x's are going up by 2 every time. What's happening on the y's? It's going up 4 every time. So as x goes up by 2, this goes up by 4. do it a couple ways. One way is you can think about slope is rise over run. So rise is the y's. So the difference between these, right, where this is going up by 4 as the x's are going up by 2, which means it has a slope of 2. Or you could do the good old-fashioned way where you just subtract y2 minus y1 over x2 minus x1. Right? Maybe. What's a slope of 2? So look at your equations. Do any of them have a slope of 2? More than one of them have a slope of 2? Q is y equals 2x, and S is y equals 2x plus 3. So let's look at a point. If I plug 3 in, I get 6. Does that work for both of those, or only one of them? Just Q. So you kind of have to